Hello, and welcome to today's webinar hosted by NXP entitled Achieve 3 times Faster Development and 40 Days Battery Life on Your Wearable Designs Using MicroEdge V on NXP i.MX RT500 MCUs. Today, we will be joined by our partners at MicroEdge as we look closer at the design of great user interfaces that differentiate from the competition, designs that leverage both software and hardware graphical engines for low-power animations. We will explore the MicroEdge V software and NXP hardware as a combined solution designed to address the evolving and demanding needs of the wearables industry with unbeatable low-power consumption. Today's presenters are Eduardo Montañez, Wearables Segment Marketing Manager at NXP, Jerome Leroux, CTO of MicroEdge, and Robert DiLoretto, Vice President of the United States in MicroEdge. Before I hand it off, I invite you to submit questions during the presentation by using the questions window in your GoToWebinar panel. We will address as many of your questions as possible at the end of the presentation. With that, let's get started. Eduardo, please go ahead.
Yeah, thank you so much, Megan. Hi, everyone. Thank you so much for attending this webinar. Very excited to share with you some amazing work that in collaboration with MicroEdge. We've had several wearable webinars in the past few months, but I find this one is especially interesting considering we've touched topics like intuitive user experiences, graphics, ease of development. And today, I think one of the major challenges with the wearable market today is extending your battery life. So very excited to showcase what MicroEdge and NXP are doing together to increase that battery life in your end design. I'm going to talk through initially a little bit about the wearables market. Being the wearables business manager for NXP, we talk to a lot of customers. Obviously, you're attending this webinar because you're interested in this segment. So you probably have some of these similar challenges or concerns or KPIs for your product. So we're going to do our best job today to talk through how we can help you meet these trends in the wearables market. First and foremost, and the key topic for today is longer battery life. It's no longer just a convenience to have your battery last in your end product, but now it's almost becoming critical. We're going to talk about some use cases that are emerging in this market that just require that the product have battery life. It could be life-saving. Always being connected is very important. So we'll talk about the trends here and how all these products are usually connected. With connection, we need data privacy. So a lot of information is being collected. You'll see use cases for health sensors, and obviously the end user wants to make sure that data is protected. Smart sensing. There's more and more sensors coming to the market that are being used not only in what you would consider a tracker or a smartwatch, but now even body-worn devices that will use machine learning in order to give you indications of the information being collected. And last but not least, and obviously a super strength of MicroEdge is the intuitive user interface. You'll see from some of the demonstrations today, everything needs to be like a smartphone. It has to have a vivid user interface. And NXP, we're investing a lot in this space, but also even inclusion of voice UI in audio playback. So these are some of the trends that we're seeing in this wearables market. I wanted to touch just on a few of the expanding use cases that we've seen just recently with contact tracing, social distancing, vitals reporting, safe zone alerts, and SOS emergency calling. These are all points of investment for NXP in the wearables market. So let's talk about NXP as your wearable technology partner. We're obviously developing devices like the i.MX RT500, which I'll showcase today for extremely friendly battery designs for wearables, smart sensing, with our investment in EIQ, software framework for machine learning, and the inclusion of things like DSPs for power efficient execution of that sensor data. And connectivity, obviously we have many radio solutions and cloud partners. Advanced security, that's just part of the NXP DNA, as you'll see embedded into all our devices. And last but not least, we're improving the user experience by working with partners like MicroEdge, but also including GPUs into our products or DSPs that will more efficiently execute these user experience functions. Let's crack open the smartwatch here and look at some of the NXP technology that we're showcasing today, but also already in the market in end products. You can go out there and buy wearable devices today that already use the i.MX RT500 MCU. You'll also see some of our other products also in those wearable devices, like our NFC, Secure Element eSIM device, or UWB technology, our PMIC, and even wireless charging. And let's not forget the connectivity pieces, Wi-Fi, Bluetooth, BLE. So let's talk a little bit more about the RT500. The RT500 is built in an advanced technology node to really extend battery life. We have demonstrated and will show today with MicroEdge up to 40 days battery life for a wearable. We also have functionality like the Cortex M33 running up to 275 megahertz in turbo mode. We have an on-chip Fusion F1 DSP from Cadence, accelerating many algorithms. We have a Vivant GPU accelerating the graphics performance up to 60 frames per second. We have many different flexible display interfaces, including MIPI, DSI. We have small packages like a 4.5 by 4.5 millimeter wafer level chip scale package. Obviously, that's a main requirement for wearables market. But then we have the flexibility of having very large on-chip SRAMs that are high performance with the ability to extend to many different external memories like serial NOR, NAND, and PSRAM. And last but not least, is this DSP does allow us to support new voice UI and voice calling use cases at very low power. Here's the block diagram. I've already touched on most of this functionality. You'll see that you have very common MCU functionality with additional rich features for the wearable market. We do have variants of the RT500 that have the DSP and remove the DSP, and likewise for the multimedia, the GPU. So before I hand it over to MicroEdge, just wanted to touch on the EVK for the i.MX RT595. This does cover all the variants of the RT500 family. As you can see, we've included a lot of functionality in here and a lot of software behind it, like what MicroEdge will provide for RT500. We have a PMIC, accelerometer, magnetometer. We have both octal SPI flash and PSRAM. We have many functions for audio and voice. We have USB. We have an on-chip debug probe. We have connectors for displays, and we even sell the separate displays. You can see here the wearable display, the 1.2-inch circular display, but we also have a 4-lane MIPI 5.5-inch display as well. So these EVKs are available for purchase today alongside the display, and MicroEdge will talk about their solutions and how you can download those and get started with your evaluation. So now I will hand it over to Robert to continue the MicroEdge piece of the presentation. Thank you.
Okay, thank you, Eduardo, and hello, everyone. There we go. For our agenda, we would like to introduce MicroEdge V for the i.MX RT500. Our product, V, stands for Virtual Execution Environment. We will also present how MicroEdge V reduces power consumption thanks to the i.MX RT500. Topics include MicroEdge V introduction, demonstration on an i.MX RT595 evaluation kit board, a presentation on battery life-saving mechanisms, and in addition, we will show and explain how MicroEdge can speed up time to market with our digital twin development environment. Next. I will now begin to introduce MicroEdge. MicroEdge provides a standard on-device platform for cost-driven electronics based on NXP's MCU portfolio. We are a global player in embedded electronics development, and MicroEdge is focused on key markets including wearables, smart home, home appliances, and others. Across these sectors, we have around 100 million devices powered by MicroEdge. Founded in 2011, we have invested $40 million in R&D and received our Series A funding. One of our key areas of value is accelerating idea to production up to 3 times faster. And this is enabled through our digital twin development environment. With over 55 employees, they stretch across countries including the US, France, China, and Brazil. Next. Our product, MicroEdge V, is an application container dedicated to embedded systems and embeds a 32-bit virtual processor called MEJ32, plus a smart memory usage optimizer along with a wide range of free libraries. MicroEdge V runs on any OS RTOS commonly used in embedded systems and can also run on bare metal. Other V components include the SDK, GUI development, digital twins, device, cloud, and IoT connectivity. Next. By decoupling hardware and software concerns across the various work teams, specifically UX, BSP, and hardware, you can streamline efforts in parallel to achieve idea to production up to 3 times faster. Here is where we simulate, validate, and finalize specifications, design, and deployment or development efforts to arrive at production much faster. This process leverages a team collaboration environment. Next. On the left, you will see a functional simulation of a smartwatch on our desktop PC digital twin. This includes a graphical display with pixel and color accuracy, buttons, touchscreen, sensors, and IP connectivity for prototypes. Applications developed on the virtual device execute the same without any change on the real device. In other words, it's the same byte code. All key stakeholders, design, marketing, engineers, finance, and even management are leveraged in parallel. In this environment, we're also able to tailor the NXP i.MX RT500 according to real needs while evaluating bandwidth, RAM, flash, power, resources, all mapped to feature design requirements. And you don't even need the physical hardware to start. On the right is a representation of the physical device connected to real hardware, in this case, the i.MX RT500. Next. This picture illustrates the MicroEdge desktop PC digital twin I just mentioned, and this will be demonstrated shortly. On the right is a picture of the real hardware. Next. MicroEdge is a gold partner of NXP, and we have a number of synergies. A main one is binary software portability, guaranteed across the NXP MCU, MPU, and crossover portfolio. This provides a build once, deploy many scenario. We will get into more of these remaining attributes as the presentation unfolds. Next. This slide shows the positioning of MicroEdge in the market. MicroEdge has been branded as the tiny sibling of Android and shares the same virtualization core technology. V is the industry's smallest embedded multi-sandbox virtualization core at 1,000 times smaller than Android. This enables us to reside on leading MCUs such as the RT500 and other MCUs and the MPUs listed. We also address a broad range of the NXP family, and you can see the segmentation at the bottom of the slide. Next, I'd like to introduce Jerome LaRue. Jerome is our Chief Technology Officer. Jerome has been part of our core development team since the early phases. Jerome.
Thanks, Robert. Hello, everyone. I will now give you more details about the MicroEdge V for the RT500. This virtual execution environment has been tailored to the RT500. It can execute high-level managed code written in Java, JavaScript, Kotlin, or Python. The V exposes the hardware capabilities of the RT500. Fast and beautiful UI, ultra-low power, multi-core support, and security. The main features provided by the MicroEdge V RT500 are multi-sandboxing, power management, UI with vector graphics, and network communication with Wi-Fi. The multi-sandbox kernel is a component that will make your device smarter. Thanks to it, you can dynamically install and uninstall applications on your device, as you can do on a smartphone or a smartwatch. The applications are managed by the kernel that provides sandboxes and controls the lifecycle of this application. The Power Manager is a central component that controls the voltage, frequency, and peripherals to reduce power consumption. The application can use this Power Manager to specify the performance level they require and adjust the configuration depending on their needs. The user interface library embeds its own graphics engine with generic features: graphical primitives, widgets, font rendering, images, touchscreen, and button events. We also have an extension to this library dedicated to the RT500. With this extension, the applications can provide even richer UI with vector graphics primitive, vector images management, and TTF font support. We'll see a demonstration of these capabilities later. Optionally, a Wi-Fi transceiver can be hooked up to the board to add network support. The MicroEdge V RT500 is compatible with many add-on libraries and allows the application to use a wide range of protocols and payload formats. We have listed here some examples with MQTT, HTTPS, CoAP, JSON, XML, etc. I will just jump in the demonstration with a MicroEdge V running both on an i.MX RT595 EVK board and on its digital twin. Here is a demo of the MicroEdge V on the i.MX RT500 processor. We are using an i.MX RT595 EVK board with a round display. The application has been written in Java and runs on top of the MicroEdge V. The touchscreen and two buttons are used to navigate through the application. We have here a menu with the applications, and we're using the touch to navigate in this list. For example, we have a compass application with a dynamic image rotation. We also have several applications that use vector graphics. The VG Mascot application demonstrates the capabilities offered by the RT500 and the Vivente GPU, with the animation of images generated from SVG files. The MicroEdge V also uses GPU to render TTF fonts. In addition, it provides libraries to do some fancy animations like this. Thanks to the MicroEdge V, a developer can use the VG library directly in Java and design great animations. This application calls the draw circle method with different parameters to create an animation. The rendering of this draw circle arc is accelerated by the GPU. The MicroEdge V RT500 comes with a widget library to develop a user interface quickly. It provides standard widgets such as labels, images, buttons, and more advanced widgets like this circle with a gradient. The position and size of the widgets can be adjusted dynamically depending on the resolution of the display. In this application, we can see an example of a graph widget. From the clock view, we can enter a menu to select different watch faces. New watch faces can be downloaded from an application store and installed dynamically. In this watch face, we are using vector graphics to draw and animate the hands. The watch face can be customized with several widgets. This one mixes vector graphics for the hands and a raster image for the background. We also have alpha blending with a gradient effect around the second's end. And that one is a low-power version of the previous watch face. In this watch face, we are updating the content of the display every second. So the processor can enter into sleep mode between each update. That's the application I will use to explain how the MicroEdge V reduces the power consumption on the RT500. That's it for the demo on the RT500 board. Before continuing the presentation, I want to show you the MicroEdge development environment and one of the major assets of the MicroEdge technology. So here we have the MicroEdge SDK. It is an IDE based on Eclipse that provides several tools and code editors. When you're developing your application and you want to test it, you can use the MicroEdge virtual device to run it. The MicroEdge virtual device is a digital twin of the real device. I will now start the virtual device. With the virtual device, you can test your application even if you don't have the real device. It works on any desktop environment, Windows, Linux, macOS. So here we have a digital twin of the i.MX RT595 EVK board. We are simulating the display, physical buttons, touchscreen. We are running the exact same application as we did on the real board. We can see that the GPU rendering is simulated too with vector graphics. Same thing for the fonts. And one interesting feature of the virtual device is the capability to control the input of the device. For example, if I open the heart rate application, I can simulate different heart rate values with the control panel. This is very convenient to test large values or very small values. If we go back to the watch face here and select this watch face, you can see how we can control the battery level and test here the battery widget with different values. So this was a quick presentation of the virtual device. It can also be used to simulate other peripherals, LEDs, Wi-Fi, Bluetooth, serial communication. It is highly customizable and can be used to test different hardware configurations. For example, you can specify the resolution of your display, number of colors, or even the shape of the display. Okay, so we'll now focus on power management on the MicroEdge V and see how it reduces power consumption. There are 3 principles to reduce this power consumption. First one is reducing active power. That's the power used when the device is active. Second principle is reducing processing time. We'll see how MicroEdge V leverages hardware acceleration to execute several actions in parallel. The last principle is reducing standby power when the device is not active. So one obvious way to reduce power consumption is to reduce the processing time. To do that, you can increase the CPU frequency. This is not really a good idea because increasing the frequency requires increasing the voltage and the energy efficiency will be worsened. But in some particular cases, it can be more efficient to run faster. I will show you that later. However, the MicroEdge V for RT500 implements dynamic frequency scaling for more flexibility. It supports 2 different frequencies, 192 MHz and 96 MHz. These 2 frequencies are the best trade-offs, with highest frequency for high performances and the lowest frequency for low power consumption. The second way of reducing the power processing time is to execute tasks in parallel. The RT500 has an impressive number of processing units with CPU, GPU, DSP, DMAs. Each processing unit is designed for a specific kind of computation. It can be tricky to configure the execution of these different cores. The MicroEdge V for RT500 will automatically dispatch the execution on the suitable processor. For example, the smart DMA and the GPU are used by the graphics engine, and the power quad by the Mac library. The UI stack that requires high performances has been optimized to use all the capabilities of the RT500. In particular, the MicroEdge V leverages the capabilities of the Vivente GPU and the smart DMA. Another optimization avoids wasting time with transitions between wake and sleep states. The MicroEdge V, a software timer, allows to schedule several cyclic tasks with a period defined for each task. The resolution of the timers can have an impact on power consumption. With a low-resolution timer, the execution of the different tasks are regrouped to reduce the number of transitions between sleep and wake modes. If you need high-precision timer, then the task may not be synchronized. This can lead to more context switches and so processing time overhead. This graph shows an example of a scheduling with a high-resolution timer where the CPU enters and exits the sleep mode frequently. And in the second example, with a low-resolution timer, the tasks are regrouped and the number of context switches is lower. Now we will dig into the MicroEdge V scheduler implementation. The virtual execution environment implements a green thread architecture. It means that all the threads started in the V are executed in only one FreeRTOS task, called the V task. So for the RT500 MicroEdge V, we have 2 schedulers, one in FreeRTOS and one in the Mesh32 core engine. This architecture simplifies the integration of the V application. For example, if the application creates new threads dynamically, we don't need to create new FreeRTOS tasks. When no application thread is active, then the V task is automatically halted. FreeRTOS is configured in tickless mode, so the CPU enters sleep mode automatically when there is no task to schedule. In addition, the application can decide to enter RT500 deep sleep mode. To do that, it needs to specify first the wake-up condition. Then, as soon as no task is active, the CPU will enter deep sleep mode instead of basic sleep mode. The MicroEdge V includes a monitoring system to help the developer analyze its application and BSP execution. We have here an example of a chronogram loaded with system view. This feature automatically monitors the execution of the V threads and RTOS tasks. It can be customized with an application-specific event. All the events are timestamped with a cycle precision. In this chronogram, we can see the periods where the CPU enters sleep mode automatically. As I mentioned previously, the graphics engine has been optimized for the RT500. For the devices targeted by the RT500, the graphical component requires high performance. In the MicroEdge V, the UI library, called MicroUI, uses several hardware executors. The drawing primitives are executed by the Cortex-M33 core or the Vivendi GPU. In parallel with that, flash of the back buffer is done by the smart DMA. If the content of the back buffer is used to create the next frame, then its content is copied by a DMA. The input events, buttons, touch, are managed under interrupt. To minimize the number of pixels to flash, only the modified area of the screen is copied from the back buffer to the display. Now, I will show you the strategies to reduce the power consumed by the RT500 when it is active. The MicroEdge V for RT500 provides a software library that controls the power configuration. It defines 6 power states that can be applied to a different component of the device. This allows, for example, to turn off some peripherals or reduce their performances. The application doesn't fine-tune the configuration by changing the frequencies or the voltage. The power manager comes with predefined configurations for each power state. So, for example, when we set to low the GUI component, it will automatically turn off the GPU. The application can also be notified when the power state changes. As we saw previously, we tried to reduce as much as possible the processing time. But sometimes you cannot do that. An external peripheral can drive part of your execution and prevent the MCU from entering deep sleep mode. For example, for the GUI, the graphics buffer content is sent to the display by the smart DMA. This action is called flush. The duration of this copy depends on the number of pixels to send and the speed of the bus. When you have a high-resolution display, the flush time can be pretty significant. And while the copy is running, the MCU cannot enter the deepest sleep mode, even if the CPU has nothing to do. We'll now see 2 different situations and explain how the application can use the V Power Manager to reduce power consumption. In these 2 use cases, we have 2 processes that can run in parallel: drawings and flash. In the MicroEdge V for RT500, the GUI stack uses 2 graphics buffers. So when the smart DMA is flashing the content of one buffer, the Cortex-M33 can prepare the next drawing and use the other buffer. So now, let's see the first situation. Here, we have the drawings that are faster than the flash. The Cortex-M33 can sleep as soon as the drawings are done, but the RT500 can enter deep sleep mode only after the end of the flash. To optimize the power consumption of this use case, we need to reduce the active power by reducing the core frequency and shutting down all hardware accelerators. Even if the drawings are slower and the Cortex-M33 runs longer, the global consumption will be reduced. And this without impacting the performances because the number of frames per second is driven by the flash time. In the second use case, we are in a situation where the drawings are slower than the flash. If we want to keep good performance, we need to accelerate the drawings.
To do that, we can activate more hardware accelerators, GPU, power quad, fusion, and so enter deep sleep mode quickly. We'll now dig into the first use case with some real-time captures of the power consumption. In both of these captures, the curve on the top shows the current milliamps. The second curve is the voltage. And the two curves on the bottom represent the activity of the smart DMA and DMA. So in the use case on the top, the drawings are faster than the flash. During phase 1, both CPU and the smart DMA are running. In phase 2, only the smart DMA is running. When the UI power state is full, the average current is 30 milliamps and the voltage is 0.9 volts. This gives an average power of 27 milliwatts. As we can see in the second capture, if we reduce both the frequency and the voltage, the average current drops to 18 milliamps, and the voltage is set to 0.8 volts. The combination of these two changes in the configuration gives an average power of 14.4 milliwatts. This is a 47% decrease in the power consumption, and that with the same performances in terms of graphics rendering. As we said before, when it is possible, the RT500 can enter deep sleep mode automatically when the application asks it. Here we will see what are the mechanisms that reduce the power consumption in this state. Another unique feature of the MicroEdge V is the Smart RAM Optimizer. This component automatically frees unused memory. It also compacts data in RAM to reduce the number of RAM banks used by the system. The same applies to the thread stacks that are allocated dynamically. The RT500 automatically powers off the unused memory banks, resulting in 9 milliwatts saving in deep sleep mode. We already noticed that a voltage reduction increases significantly the battery life. When the system enters deep sleep mode, the MicroEdge V automatically reduces the VDD core to 0.6 volts. And as we said before, most of the memory banks are powered down and their clock sources are also turned off. We'll now see a typical example of a simple watch face that refreshes the display content every second. In this use case, we are drawing the background image and 3 hands. The power state of this application is set to low because the graphics rendering doesn't require high performance. Thanks to all the optimizations we described previously, we can reduce the processing time, the active power, and the standby power. For this watch face, the average power that has been measured on the RT500 is only 270 microwatts. To estimate the battery life for a real product, we define a typical watch configuration and representative usage profile. Here is our watch configuration. So we have the i.MX RT595, an AMOLED display, a touch controller, Bluetooth low energy, a PPG sensor to monitor heart rate, and a vibration motor. Each of these components can be in different states that will impact the power consumption. For example, the display can be turned on or off, the RT500 can be in active mode, sleep mode, or deep sleep mode, etc. The usage profile we defined specifies how long every peripheral stays in each state. Result of this study shows that a watch with 350 mAh battery can last about 40 days.
in these configurations, thanks to all the optimizations presented today, the RT500 consumes less than 20% of the battery. Thank you for listening to this presentation. Now we'll let Robert conclude.
Jerome, thank you very much. I think we have a conclusion slide here next. Great. As noted on the right-hand side of the slide, customers can achieve significant reductions in R&D costs, time to market, and embedded software complexity. In conclusion, I hope we were able to highlight these facts, along with how MicroEdge leverages all RT500 attributes, including UI, UX, low power, dual core, security, to achieve up to 40 days low power efficiency. Below is the link to help get started with our virtual device, and that is microedge.com/RT595. Besides getting a full view of our capabilities and website on microedge.com, please refer to developer.microedge.com. On this developer section, you'll be able to download free starter kits to test and evaluate MicroEdge V. So I want to thank you very much on behalf of MicroEdge, and I'll turn it back over here to NXP.
All right, thank you so much. Thank you to all the presenters today. And we are now entering our question and answer period. So let me go ahead and share my screen. Hopefully everyone can see this. As a reminder, to ask questions, please submit those using the question panel in the GoToWebinar panel at the right. We will be happy to field those questions as they come in. We have a few queued up from during the presentation. So I will start with the first one, I think directed at Eduardo. Eduardo, what is the power consumption of the i.MX RT500 series MCUs in terms of microamps and megahertz?
Thank you, Megan. Yeah, this is an excellent question. One I really enjoy because it has a lot of variables related to answering that. Typically, when engaging customers, that's usually the first question I get, and we have to go through a little bit of an explanation of some of the things that can cause that microamps per megahertz to vary. So there's not one answer. Like I would say, the power profile will vary. The active power profile will vary depending on a couple of things. So you got to think about what code you're executing. You know, how often is this memory that this code is being executed? What's the ratio of access? So, for example, if you're running like a WA1, which I know a lot of vendors use that particular use case for your microamps per megahertz, they you know, one thing you don't understand is that likely that WA1 loop is just executing in cache, so it's actually not accessing some type of non-volatile or system RAM component, which is additional power consumption. So what we do in our data sheet is we give you a couple of different profiles. We give you that WA1 because, like I said, a lot of vendors do you know, use this as their best number, but we also do code execution like CoreMark or FFTs for our DSP to show actual functionality that leverages the memory and memory access. So that will play into what your power profile looks like. It's also very much dependent on the efficiency of your supply. So just to kind of give you a general example, if you were to use an efficient supply, you should see typically somewhere between 25 and 35 microamps per megahertz. What we like to focus on, as you can see from the presentation today with MicroEdge, is overall system power. So working with you to maximize the duty cycle between deep sleep modes and active power, so we can increase that battery life, like shown today, to 40 days. So hopefully that helps answer that question. It's not an easy one, but one I definitely enjoy talking about.
Very good. Thank you, Eduardo. All right. We have another question come in. This one, I believe for Jerome. Any idea of the bill of material cost for this typical application? I assume the one shown in the demos.
Yes. For the bill of material, usually we are distinguishing the size of the MicroEdge V itself. We are distinguishing that with the BSP, so all the NXP SDK, and the application. So for the demo we did today, excluding all the, if we don't talked about the network libraries, SSL, etc. The MicroEdge V itself is about 200 kilobytes of flash memory, with the core engine, the Mesh32 core engine, around 32 kilobytes. So it's included in these 200 kilobytes. And for the application, the code of the application is about 120 kilobytes of flash. And actually, the biggest part of the application are the resources, so images, fonts, etc., with about 3 megabytes of resources. These resources can be reduced using more vector graphics. In this demo, we are mixing up vector graphics and raster images. And in addition to that, the BSP, including the RTOS, the drivers, the NXP SDK, it's about 400 kilobytes. So if we exclude the resources for this demo, we are at about, let me compute that, 800 kilobytes. And for a low-end V, size is typical 122 kilobytes with a graphical stack. And if we add network, Wi-Fi, SSL, and the drivers for the Wi-Fi, we can add about 300 kilobytes.
So Jerome, I want to jump in here. This is Eduardo.
Yes.
I see that I think the information provides obviously going to be very useful from a memory footprint perspective. So thank you for that. I think there's also a second part to this question, which is related to the commercial piece of a BOM for a wearable of this kind. That question is really going to depend on the system components needed for your end application. So for example, I'm talking to customers today that don't need the DSP function, don't need the GPU. They're just designing a wearable that is doing some sensor fusion, some indicator type processing, and maybe is connected to a smartphone through BLE. So maybe in that case, they can use one of the like for example the RT500 variant, which is less expensive without the DSP and GPU functionality. We do have an option for a 3 megabyte on-chip SRAM device there too, so there's some cost savings there. From a BOM perspective, really it's going to depend on all the components you select. So you can, if it's just BLE, typically adding BLE is somewhere between, I'm just going to give you approximate numbers. It's obviously volume dependent, but 50 cents. If you want to add some memory, external memory, that could be anything from 10 cents to 30 cents. For the device itself, I mean, obviously we'll work with you or your distributor directly, but for the RT500, depending on which variant, it could really vary from $3 to $5, depending on which variant, what package. You know, we have a wafer level CSP which has less IOs, but it's much smaller footprint. So there's obviously a value for that, but also we have a fan out wafer level package which has a lot more GPIO functionality. You know, if your application requires it. So overall, the BOM cost will vary, but just trying to give you some ballpark estimates there on what you should expect for your end application.
Very good. Thank you so much. Our next question is, what voice software solutions are available for the i.MX RT500? That probably goes to you, Eduardo.
Sure. Yeah. So obviously today we touched on a lot of low power functionality. I know that MicroEdge showed some of the adders for sensing and for connectivity, but one of the up and coming items or trends that I'm seeing in the wearable space is voice. We have a couple different options. So inside NXP, we have available for the mass market a solution called Voice Intelligent Technology, which uses a text to model development in order to quickly have a wake word and voice command capabilities added into your product. So that's something you can check out and download for the RT500 SDK. We've actually done some collaboration with MicroEdge and inclusion of that voice technology into the demonstrations that you saw today. We didn't focus on that today, but we do have that already in place. We have also just recently acquired software company for voice, Retune DSP, and we're quickly integrating many of their solutions into our NXP voice portfolio, specifically the RT500 for wearables. Some additional benefits you'll get from that software would be things like an AFE, if you want to do noise reduction, beam forming, echo cancellation. You could also leverage their Conversa. So this is one I'm very excited about. We're working on two-way communication. So we talked about the emergency calling use case. That's something that we're actively working on for the wearable market with these products.
All right, very good. Thank you, Eduardo. Okay, our next question comes in probably to Jerome. Can MicroEdge V be used on top of any RTOS?
So yes, so for this demonstration, and we use FreeRTOS, but MicroEdge is OS and RTOS agnostic, so it can run on different RTOS. We are supporting the main RTOS, MicroEdge OS, MBOS, FreeRTOS, DeFi OS, and also it can run on a bigger operating system like Linux or QNX. And so our customers can customize the MicroEdge V for their specific system, and we have even some solutions for very low-end devices that runs bare metal without any RTOS.
Very good, thank you. And while I have your attention, Jerome, let's try another one. What are the peripherals managed by MicroEdge V?
So we saw today that we are managing all the graphics, so the display, the touch, physical buttons, LEDs, and connectivity with Wi-Fi and network. We are supporting also other connectivity like Bluetooth, Bluetooth low energy, Zigbee, any local connectivity UART, SPI, etc. We manage also file systems. So same thing as for the RTOS, MicroEdge V can run on different type of file system. And the other peripherals we are managing. We have industrial protocol also that we can manage. That's pretty all I have in mind here.
Okay. All right, very good. It looks like we have another question in. Time for just a few more. This one probably goes to Eduardo. Will NXP introduce a watch like EVK? This would make it easier to evaluate in real world conditions.
Yeah, that's a good question. We're not actively within NXP developing a form factor watch, mostly because we see so much variation of the type of products that our customers want to develop with a product like RT500. So what we have is the EVK form factor today, with many of its capabilities on there and the ability to plug a circular display on it. With that said, our partners are working on things like form factor designs. We're working with some ODMs that's not yet released, but we do have plans to do that with some of our partners. So not directly from NXP, but distributors or ODMs are actively developing these kind of form factor watches.
All right, great. Thank you. All right, Jerome, another one in. Can you give us more details about dynamic download of applications?
Yes, so that's something I mentioned during the presentation, and we didn't demonstrate that. But as we can do on a smartphone or a smartwatch, thanks to the MicroEdge V, you can download applications to your device and install them dynamically. So without the need to reboot the device, you can install, uninstall, start, stop applications. And all these applications are sandboxed. And so the MicroEdge V kernel will control the accesses, different accesses of the applications. In addition to that, the device can connect to an application store to list the applications and install the applications.
All right, so, very good.
Yeah, sorry. Just to mention that, of course, this dynamic download option is optional, and you can just build a static single application and don't use this feature.
All right, very good. Thank you so much. And with that, we are approaching the top of the hour, and there are no other questions waiting in the queue. So with that, I will thank all of the presenters for their great content and demonstrations and presentations. I also want to thank everyone that joined us today. We appreciate your time and interest in the subject matter. And we invite you to follow the links later this week that we send out to access the recording and the presentation materials. So be on the lookout for that. And with that, I want to thank everyone and wish you well. Have a nice day. Bye-bye.